Hi, my name is Karen Howe, and this is our module on an introduction to generative AI. So here's what we're going to cover in this module. How generative AI differs from other kinds of AI, what goes into making a generative AI model, the difference between text and image generators, and finally, major challenges with generative AI. And as a reminder, don't stress. If this is your first time engaging in the technical details, use this as a way to familiarize yourself with terms and concepts. And if you already know some of these details, use this as a way to clarify your understanding. Of course, you will be getting this slide deck, so treat it as a resource and refer back to it as needed. So I want you to first think in your head for a moment what you know generative AI to be. And then I want you to figure out, where would you place generative AI in this diagram? I'm going to give you a little bit to think about it. So generative AI is just a smaller part of deep learning. So we talked about how AI is our suitcase word, and machine learning is a subset of AI that uses data. And deep learning is a subset of machine learning that uses big data. So generative AI is a subset of deep learning that uses massive amounts of data and big compute. So generative AI is inheriting all of the features of machine learning, namely the probabilistic nature of it, all of the features of deep learning, namely the black box nature of it, and it has some unique characteristics unto itself. Since generative AI emerged, people sometimes now call everything else in machine learning that's not generative AI predictive AI. And that's not actually referring to something new, it's just renaming something that already existed. So what makes generative AI different from predictive AI? Generative AI is ultimately about learning from data to generate more data. So where the new data appears in the machine learning process has shifted. In predictive AI, you're feeding new data into your model and the model is giving you some kind of answer. And in generative AI, you're prompting the model and the model is the one that is spitting out new data. Most generative AI models today are based on transformers. And there's a big asterisk here that this is true today, but that could change one day. As we've mentioned, throughout the history of AI development, the techniques have shifted depending on what's in vogue and who has the money and the power to determine the direction and trajectory of AI development. But for now, it is based on transformers. And what are transformers? As we mentioned, there are all of these different types of neural networks that you can think of as different tools in a toolbox, and each of them have their unique architecture with a specific specialization. So transformers are just one tool in this toolbox. And what do transformers specialize in? It turns out that they're really good at finding long-range patterns in sequences of data. What does that mean? Sequences of data refers to something like language. Language has a specific order to it. You cannot read a sentence from end to beginning. It has to be read from beginning to end. So that is what we mean by sequential data. And before transformers, language models only considered words in their immediate context. So if they were analyzing this famous Shakespearean poem and they were trying to analyze the word gold, they would only look at the words directly around gold. Is his gold complexion dimmed? And the language model might conclude or predict that gold here refers to a person with golden skin. But it turns out if you actually read the entire poem, you realize it's not referring to a person, it's actually referring to the sun. And you only start to figure that out once you get the other clues, like a summer's day, the eye of heaven shines, nature's changing course. And so this is what transformers are really good at. They will analyze the sequential data and they can consider words in the whole context. and learn to relate the words that seem most relevant to one another, regardless of how close they are to one another. This helps the model contextualize each word better, and that's part of the reason why it's much better than previous language models at tasks like summarization or generation. So if you remember back in the day with iPhones, when they first came out with text prediction, and you would try to write sentences just by clicking the next predicted word, it would construct these sentences that made absolutely no sense because there was no coherent through line from beginning to end with the sentences. And the reason why we were able to go from that kind of very simplistic text prediction technology all the way to something like ChatGPT, which can seemingly be coherent for not just sentences, but paragraphs and essays and full conversations, is because of the move to transformers, because of the transformers' ability to do this long-range analysis in sequential data. So the interesting thing is transformers can also be applied beyond language. They can also be applied to images because images are actually also sequences of data. If you think of images as pixels, those pixels come in a particular order. And transformers can analyze images by considering not just the pixels that are nearby one another, but also pixels that are far away from each other, but somehow related. So they're better at analyzing the composition of an image than other types of image analysis techniques. Transformers also work for analyzing genetic sequences. You can use them to analyze the sequences to understand how genes that are very far from one another might actually be related and working in tandem to manifest as a particular trait. And I find this actually to be one of the most interesting applications of transformers. So if you've ever wondered what ChatGPT stands for, GPT refers to Generative Pre-trained Transformer. We now know what generative means, it's referring to generative AI, and we now also know what transformers are. But what does pre-trained mean in the GPT? Well, let's for a moment go back to this diagram where we have our two steps of machine learning. We have the training step and we have our inferencing step. Generative AI also has these two steps. Again, it inherits everything to be true about machine learning. But there are now a few more sub-steps in the process. So when it comes to training, this is what the typical training pipeline now looks like for generative AI models. And there are different stages in the training process called pre-training, fine-tuning, and RLHF, or reinforcement learning from human feedback. The acronym GPT, the P, stands for this first stage of training, pre-training. And the reason why it only includes the first stage in the acronym, not the others, is because OpenAI, when it first started developing generative AI models, initially only did the pre-training process and later added the fine-tuning and RLHF process. So the ChatGPT name is sort of an overhang of what they originally did before it became kind of modified over time. So let's walk through what each of these steps look like. In the first step, pre-training, I know the pre-training name makes it sound like it happens before training, but it is actually step one of training. And yes, this is confusing. AI developers are not always the best at naming things for a lay audience. But in pre-training, what you're doing is you're taking a giant corpus of data, the data that you scraped from the internet, and you're feeding it into your transformer neural network to create what's called a base model or a base GPT. That base model is essentially learning the general structure of language, but it's not specialized to any task. So it's learning the grammar, the syntax, things like that. But if you want to specialize the model to something specific, let's say you want to specialize it for conversation, you need to go through the fine-tuning step. That's ultimately how OpenAI gets from a base model to something more similar to ChatGPT. You can also take coding data and fine-tune your base model to create something that is better at code generation. And this is also what a lot of the different AI companies are doing to develop AI coding assistants. And that is essentially what happens in the fine-tuning stage. Then the last stage is called RLHF, or reinforcement learning from human feedback. And in this stage, you're essentially taking contract workers, humans that are doing data cleaning and data preparation, and they are essentially doing a process to make the model what companies call quote unquote safer. And what I think is helpful to just think of as making it more consumer friendly. Because when you are developing a chatbot that should be able to talk about any topic, you run into a challenge where you do not want the chatbot to spew toxic content, hateful content, or potentially illegal content. And in order to extricate all of that out, part of the process is to essentially do RLHF. And so what the human contract workers are doing, they're chatting with the model back and forth. And every time the model spits out a bunch of outputs, a bunch of generations, human contract workers will upvote or downvote the answers and also show the model what is a better answer to give. The inferencing stage has also gotten more complicated. Typically, when users are interacting with models, they are not interacting with the naked AI model. They're interacting with an AI product that has dressed up the model in lots of extra layers. So companies are actually doing a lot of extra work to try and make their products into an overall good user experience. For example, they add an interface to the model. So that interface might be the website for ChatGPT or the app for ChatGPT. They also will add a content moderation filter on both the input and the output that's pinging the model and coming back from the model to try and filter out more abuse and hate speech. So we already mentioned that the RLHF process tries to minimize toxic content and make the model more consumer friendly. This is sort of another added protection to try and really prevent these models from spewing dangerous content. You might also have what's called prompt augmentation, and this itself could be done with a GPT model. So when you prompt something like Dolly 3, you might notice that it will then show you your prompt basically being elaborated on. So there are 4 different types of elaborations that might come out that just make your prompt more detailed, more specific. And part of the reason why companies started doing this is because they realized to get the best results out of their models, the prompts should actually be as detailed and specific as possible, but users don't typically write that way. And so they will take a simpler user prompt and then use a GPT model to make it more detailed and then ping the model to try and get the user the best results. Image generators are really similar to text generators with one main conceptual difference. So they still use transformers, but they also use this thing called diffusion, which is what Stable Diffusion is named after. And again, big asterisks, the use of diffusion is true for now, but that could change one day. And before we actually talk about what diffusion actually is, I want to talk about how it is that image generators can use both transformers and diffusion. Well, we've talked about how neural networks have different types of architectures. And for large language models, the architecture is the transformer. But what we didn't mention is that they also need an objective for training. So when you're training a transformer to become a large language model, the objective that you give it is to predict the next word. And that's what makes it really good at ultimately analyzing text passages and then being able to summarize or generate long passages as well. With image generators, the architecture is still a transformer, but it's slightly modified to be better at analyzing images. So it's called a vision transformer. And AI developers were trying to figure out what to make the objective such that it was effectively the equivalent of next word prediction in large language models. And the objective they came up with is diffusion. So that is why image generators can use both transformers and diffusion. So now we get to what is diffusion. Well, the thing that AI developers discovered is the equivalent of next word prediction, is essentially taking images and slowly corrupting them with more and more static until the image is essentially unrecognizable, 100% static, and then training the vision transformer to recover the image from that static. So they're taking millions of images from the web, they're doing this corruption process, and they're training the vision transformer to recover those images. And it turns out that over time, the vision transformer gets really good at recovering images from complete noise. And that's part of the reason why, if you've ever seen visualizations of DALL-E or Stable Diffusion working, it sort of shows a static square and then an image slowly emerging from it. AI developers essentially learned how to guide which kind of image emerges from the static based on a user's prompt. So we've already talked about how generative AI inherits all of the features of machine learning and all of the features of deep learning, but it also has unique challenges. Here's the biggest one. When you are working with such massive volumes of data, it is really hard to know what is actually in that data. So AI developers, it would take them way too long to manually comb through their giant corpuses to figure out, catalog, analyze exactly what's in the data sets. And it would also take way too long to manually take out the things that they do not want in those data sets. So what they do is they use machine learning models to analyze the data, and they use machine learning models to curate the data. And as we've already mentioned throughout this course, machine learning models are not 100% perfect. And that means these giant corpuses are riddled with all kinds of strange things. There's disinformation, factual errors, misconceptions, conspiracy theories. There's also plenty of valid stuff like short stories, science fiction, fan fiction. But the challenge is when you're jumbling all of that together into this one giant data set that is then meant to train generative AI models for all different kinds of tasks, including something like research, something like fact-finding, something like search, you're going to end up with models that actually have strange behaviors and might not be performant in those things. So this is the root of a lot of generative AI problems. And to underscore what I mean when I say that there's just a lot of trash in these data sets, there was a study that was actually done at Stanford University in 2023 where researchers analyzed an open source image dataset that had become really popular for training commercial image generation systems such as Stable Diffusion. And what they found is that in this dataset called Lion 5B, there were actually thousands of instances of both suspected and externally validated child sexual abuse material. And so this was the kind of data that was going into the training of generative AI systems. So when there's very little understanding of the data that goes into generative AI models essentially end up exacerbating a lot of the challenges we already discussed with machine learning. So there was this trio of stories that explored how discrimination is rampant within image generators. Bloomberg found, for example, that image generators almost always generated CEOs and engineers with light skin. They almost always generated social workers with dark skin. And women were also consistently misrepresented. This kind of discrimination did not, in fact, reflect the reality of the world. So women make up 39% of doctors in the US, but they were only making up 7% of the results that were coming out of these image generators. Generative AI models also suffer from what we've already talked about with machine learning models only ever producing approximate answers. So next word prediction leads to very convincing probable sentences, but probable is not the same as accurate. And the accuracy of a generative AI system really depends on its data. That's why in the generative AI context, this is how you end up with what the industry terms hallucinations. So this is the term that refers to when chatbots or other generative AI systems produce things that are incorrect. And what I say on this slide, generative AI ultimately is about remixing data, but it is not about retrieving information. And this has been one thing that companies have really confused with their messaging by trying to push generative AI systems as a new generation of search or a new fact-finding tool, a new research tool. Earlier this year, Apple ended up having a really embarrassing flub where its AI-generated news alerts contained serious errors, including this particular headline, where it summarized the phrase CEO shooting suspect Luigi Maggioni to Luigi Maggioni shoots himself. Ultimately, the way that they designed the feature also made it look like this particular headline was actually written by the BBC rather than being re-summarized by its feature called Apple Intelligence, and it led Apple to completely pull the feature. So when we think about generative AI in the context of journalism, this is, of course, also a cautionary tale. And the BBC released a report in February of 2025 where they tested OpenAI's ChatGPT, Microsoft's Copilot, Google's Gemini, and Perplexity on questions about the news. And they found that 51% of all AI answers to questions about the news were judged to have significant issues of some form. 19% of the answers, which cited BBC content, also introduced factual errors, incorrect factual statements, numbers, dates, and 13% of the quotes sourced from BBC articles were either altered or didn't actually exist in the original BBC article. So this is for sure important to keep in mind if you decide to incorporate generative AI into your own practice as a journalist.